Hello there, I'm Greg Eva. I work at PTC, and like many others, I have struggled over the years to know what's going on with an application running in ThingWorx, what's happening effectively in a performant fashion, how do we make a health baseline, how do we understand where outages are coming from, and how do we quickly diagnose potential issues that arise. If any of these things are types of things you struggled with in the past as a ThingWorx developer, system administrator, or architect, today I hope to blow your mind. So this isn't the first time I've done knowledge sharing on the topic. There's some other videos, a series of them around using Grafana and Prometheus to do just this. However, there's some challenges with the Prometheus-based approach. And that is that a lot of the applications that are providing the metrics aren't natively equipped with those Prometheus metrics. ThingWorx is, but the other ones are not, like the JVM, like getting SQL metrics, like getting metrics from the host, for example. So in order to set it up holistically, we have a lot of different Prometheus exporters that we need to set up. Those need to go on to the host. We need access to get them on there. It's additional configuration. It's additional components that need to go on there. And although this can obviously be automated, it's additional things that need to be set up. It takes time, and if we have multiple environments, that can be quite burdensome. Also leaves room for variation between our environments. And quite pointedly, you know, a lot of the remarks that I've gotten from people are we don't have the time to do that. It's a pretty big investment to be investing there. Or on the counter side to that is I don't even have access to those environments. You know, our IT or our security departments lock those environments down. I can't even change them, which is obviously the case for production environments often. So the approach that I'm going to share today is actually an enhancement that's been built on some past experiences. So there's a number of foundational elements that we're going to go deeper into. But a couple of the benefits about what we're going to look at today is we don't need any access to the host environment. We don't have to install any specific exporters or there's one agent that's required, but it's only on the monitoring side. And we can set this up in the same fashion using REST API on multiple environments. So I can also, same dashboard, same metrics collection, same polling agent, you know, across your dev, test, QA, pre-prod, and prod environments. So, yeah, why monitor, I think, is one maybe I haven't touched on enough. You know, it's one of those that I really don't understand why there's so many people out there that don't monitor. I do understand that it's a challenge, and that's really one of the things that I wanted to address with what I've put together here with a colleague of mine. Performance, ensuring the expected performance is met is a really big one. I think that comes to mind often. And that starts with when it's operating well, because when we're writing code, when we're building something, we need to know how it behaves so that when it ceases to do so, we also know what we should be able to expect. And when you have slowdowns, frankly, it's I don't want to say it's too late, but it's far too long in the journey to be able to actually do something beneficial about it. You're really just going to be facing fires and trying to put out fires at that point. However, if we already have a monitoring in place, we can diagnose and troubleshoot whether it be health or performance issues in a much faster manner. And one of the really cool things is we have this time machine to be able to go back in time and be able to say, you know, we've been getting more and more complaints from users. We've been noting such and such of a behavior. The memory usage has been going up over time. We can look across the landscape of the metrics that have been collected over the past quarters or even years and note that some changes have been made and you know, see when those changes were made and what they could eventually be related to. So a couple of enablers that we need to do this. This isn't all magic. It's quite magical, but it's not all magic. The first is the T-sample polling application that a colleague of mine wrote a number of years ago back in ThingWorx 8.5, before we had the open metrics endpoint exposed on ThingWorx, and this uses the REST API as well as the native ThingWorx performance metrics API to get the performance metrics from across the various systems. These are the metrics that you'd see in ThingWorx. That's its core functionality. It takes those, it puts them into Influx Db. What we've done here is we've enhanced this to essentially go above and beyond and leverage a couple of other extensions. One is called the Persistence Metrics Extension, which gets us metrics about the persistence providers, because the persistence providers that we're using, whether it be the core ThingWorx persistence provider or additional data persistence providers, don't provide us any metrics natively in ThingWorx. We can get some of those through this extension directly getting into the Java classes, and those are going to be exposed using some resources and available over REST API. And the third one, the most powerful one and the least kind of pre-configured, is the Jmx Exporter Extension. And this one's really cool because normally in the previous things we did with Jmx and looking at Jmx and MBean attribute capture, we went through or Visual VM, right? Visual VM, we have to set up this gem export, there's security implications to it, creating users, SSH tunneling to the whole thing. From my perspective, that added a lot of overhead and configurations as well as potential security risks. What's really cool about this Jmx extension is that we drop it into ThingWorx as an extension, so it's running within the JVM, and we can call out specific MBean attributes that we want to pull back from the running JVM, so we don't have to even turn on Jmx remote management at all. So with that, I've used so with the combination of these three elements, the ThingWorx performance metrics, some specific persistence provider metrics to call out the names of the persistence providers, as well as the Jmx exporter, I've built a T-sample configuration file that's calling out the specific metrics and is capturing and collecting them into the Influx DB, as well as a dashboard on top of that to display and render them in standardized fashion. So this was a very long process. Don't want to give the impression that it was something that I set up quickly. My hope in sharing this is that those efforts that have been done up until now can be shared and used by others, because although this approach doesn't tick all the boxes, there's certainly some gaps in it and some things that aren't great about it. One of the gaps is we don't have visibility on the database resource utilization. Another one of the gaps is just how the metrics are kind of shown in some of the graphs. It's the queries are not as performant as they could be, and the reason for that is the dashboard's purpose has been built to decompose specifically many persistence providers. So we're essentially summing values together so we can have the kind of overall view of all value streams, for example. But then if we want to go into specifics, to say I have a persistence provider for a DB, like an archive DB, or like a customer specific persistence provider and DB connection, then I can just select that particular customer and be able to kind of filter down in order to help going through an environment where you might have many persistence providers. So there's some kind of good and bad that come of that, but as I say, that's what it's been designed to do. So without further ado, let's get into it. Yeah, nothing more to be said. I'm going to start to show you how it's set up and how you can get it running on your own environment using the document that's provided, the configuration file, the T-sample agent, those extensions, and the Grafana dashboard. Start with just the basis of this, right? Come into ThingWorx, monitoring, subsystems, event processing, here we got the subsystem, here we got the metrics, right? These are performance metrics for the various subsystems. This is the core of the of really what we're after when we're talking about monitoring ThingWorx, is looking at these particular values over time and how they change, right? They go up, they go down. We execute tasks, we queue up tasks, we invoke more threads, we free threads. Same with the connections and database pool sizes. So these are really a core set of these are what we're going to be looking at. Value stream processing, you see you've got the name of the persistence provider here, as well as the metric name and the values over here. Main part that this was, T-sample was built to do this using the REST API. Next part is if we have a look at the down here, the resources in TS persistence metrics. This is an extension built by one of my colleagues in tech support, hence the TS. And I guess we want metrics. We want the metrics heading. And here there's three services in metrics: get DB connection pool metrics, get metrics metric value by name, get persistent property processing metrics. It's really only one of these that we're interested in, persistent property. Yeah, this is what we're going after. These metrics that are going to be shared here can be very interesting and are shown on the dashboard, but from what I've seen are not necessarily always entirely accurate, certainly from what I've seen. Could be for varying reasons, but what this is showing us is we select the persistence provider that we're interested in, and it's going to show us the metrics around the connection pool for that persistence provider, because a persistence provider is a database connection pool. And here we see there's 5 connections established presently to the database. 5 of them are idle. So this is super helpful, because these few values are just not available in ThingWorx anywhere. We can get at them through Jmx using the C3PO database connection pool manager. We're going to have a look at that, and we're going to get a lot more metrics than this, and hence why we're not really going to use these metrics. So let's just close that out. But this stuff, if we're talking about prior to ThingWorx 9, these particular metrics has to be the modeled provider, so that we can't put a data provider in here, because only the model provider can be a persisted property provider. But what this is showing us is, forget about all the names over here, it's more in the context of a stream, but this is showing us the number of persisted properties. So when we have a property that comes in and it gets persisted to the property VTQ table, these metrics are going to show us how many times that has been done, as well as the configurations to do so. I wouldn't suggest tweaking these configurations. Really what we want to know, other than threads potentially, what we want to know is how many are happening, because this can be extremely impactful and harsh on a database to be doing too many persisted properties, and it's a really common screw up, I guess, is a nice way to say it. But because there's no way directly within the platform of seeing it, you need something like this to be able to get access to it. It's also available, that those values are available on the Open Metrics endpoint, but they don't really come to the forefront, and that's one of the things we're going to raise to the surface. So coming back to the mashups, the other thing that the last part that we're going to look at is Jmx Extension. So here the Jmx Extension is a collection of services built by the same individual in technical support, and a little bit of a different focus using services, but also this mashup. I've been using this mashup as a tool to analyze and to find, kind of navigate the tree, right, without you needing a JVisual VM. And here you can see you just hit enter in the mbean filter up here, a star colon star, and we get the tree that starts to show up. And this is kind of important. I'm showing you this not only to understand how it works and how it relates to the ambient attributes, but also there's a high likelihood that depending on what version that you're on and what JVM that you're using, um, or if you are doing anything more custom, then you might have specific ambient attributes that you want to remove from the configuration or add to the configuration. So I have done my best to set up. Actually, I think it was done on two different configurations. It's been a while, so I've forgotten. But I think there's two different JVMs that are being used: 9 and version 11, AWS Corretto. But and they have slight variances in how they work, specifically around the garbage collection and generational memory pools. But just kind of picking one of these, you have to click this show preview up here, and you'll see we start to get some preview values that show up here that tell us about the JVM memory heap used and status. And these pool 2 ones, these ones are all about the database things. The database things use the Apache Pool 2 or DBCP2 as it's also known to handle those database connections. So this is for that secondary data persistence provider that I have. This is handling that database connection pool here and gives us some metrics around its busyness and number of connections that are established. And then the one down here, this is the core one for the persistence providers, all ThingWorx persistence providers other than Influx. Go through the C3PO and here we can see these pool data sources. And, this is a little bit hard to manage. This is one of the things, there's been some tweaking on the T-sample to manage this better, because even in Prometheus, this is very challenging because these random tokens change every time we restart ThingWorx. So, but in any case, one of these is a persistence provider. We don't necessarily know which one it is. But we can potentially, if we had some form of identifiable figure in the values here, we could identify it this way. If we, for example, had a lot of them here, we've only got 2, so we know it's one of 2. And we can look at, something like thread pool num idle threads, or there's actually one that's static in here that it's called helper threads or thread pool size. I think it's this one's thread pool size 16. We can use this value right here to cross-reference to our persistence provider in ThingWorx and look for something that has 16 threads and configuration. And what do we find? Look at this, ThingWorx persistence provider, 16 helper threads. The other one I've configured only with 4, and part of the reason for doing that is to give a little bit more horsepower to the primary persistence provider and less to just the secondary data provider. But it was also to call it out for this purpose and give it a unique identifier so that it could be found this way. Yeah, as I say, you might get some errors if it's looking for metrics that aren't there. You can clean those out in the configuration file. You can also search around here looking for other ones that you might be interested in. There's a ton of interesting stuff in here, also specifically in the Catalina if you want to look at Tomcat related things. Let's get over into the next part, which is pulling these all together. And so here I'm on virtual machine Ubuntu that I'm running the T-sample agent, and it's you know what, maybe I should just take a break here. Yeah, I wanted to go over to this. So you can see there's a ton of metrics in here. One of the things that I was inspired to try and accomplish here was that I just mentioned Tomcat. We're talking about a bunch of the JVM ambient attributes that are in there, and previously I had different dashboards, different approaches for getting host metrics like CPU, free host memory versus JVM memory versus number of connections that are coming into Tomcat. And I was kind of scratching my head there, going, wouldn't it be nice if we could build a picture that brought some of those things together and told us more about the whole running system and not just about ThingWorx? So that's exactly what I've done. And although it's not perfect, we don't have things like disk IO or network stats. for example, coming through in here as I recall, but this is using the node exporter, and we can see here a Prometheus node exporter that we can get stuff like CPU usage, number of CPU cores, overall system memory free specifically, right? This means how much memory does the system have free, isn't looking at it from a ThingWorx or JVM perspective. So that was kind of what I was going for, and I mean the Tomcat stuff as well has Tomcat. Yeah, so the Tomcat things as well, very, very important for, understanding network traffic, understanding threads, understanding connections, how those are changing over time. And so I wanted to try and, use this instead of having the Jmx exporter that's configured like I'm using in Prometheus. Basically, I wanted to build tsample into a sort of Jmx exporter that could just be loaded into ThingWorx itself. So coming over to tsample, the tsample tool, you'll find details of its use and setup if you just search for ThingWorx performance monitoring with Grafana, with some diagrams. And when my colleague set this up, it was really focused on giving people the tools to be able to build this. And so here what I've done is we've enhanced this solution approach, taken it farther, as well as pre-building everything for you. So it's a question of implementing things relatively quickly versus still setting things up from scratch, i.e. picking the metrics, i.e. building the dashboards, etc. My colleague has also added a ton of cool new features and capabilities to this, including available for different platforms, and polishing it a little bit. We've built the configuration file options out, and there's a couple of things in there we'll get into when we look at the configuration. Let's look at the configuration. So here we can see in the first part here, this is really essentially calling out those core platform subsystems that we want to pull the metrics for. And this is the initial architecture of the tool: stream processing subsystem, value stream processing subsystem. You can see some comments in here about being able to do things split desk as prefix. This is the part where we're going to take the name of the persistence provider off and kind of set it into the database aside. Platform subsystem, this is the core metrics we'd just find for ThingWorx platform, etc., etc. You could add another one in here if you wanted to, just add the name in there, or remove them, or put enabled false. And then here we have essentially as many sections as you want. You have a ThingWorx server section, and I have this ThingWorx West Europe one where I'm essentially configuring essentially just classic ThingWorx configuration for REST APIs, the address, an app key, and then here use the above mentioned default subsystems. Here it's going to pull in any of the details about the connection servers. And then this is kind of where we start to get a little bit more complex, is this Jmx metrics section is going to use the Jmx extension services to pull in whichever of these Jmx MBean attributes have been configured. So there's kind of a fair amount. I had to kind of hack this a little bit. There's, depending on the JVM, there's different options that kind of work. Normally, you don't need to specify things entirely like this right here. Comments pool to generic object pool name works in some situations. In other situations, you can see here, like this one here, the name actually shows up first and not like this. If the name showed up second, then you can just put common name and it'll get all of them, all of the memory pools. But just the way that they're coming back from the extension that's being used here, it's not always the same. And so I had some strange results. And, let's just kind of quickly look at that to see what I'm talking about. Memory pool, Java Lang G1 Eden Space type memory pool. Java-lang G1 eating space. Yeah, here, memory pool. So there's one thing about the hierarchy, and then, but it's specifically down here, as you can see the object name, it says type memory pool common name. So technically speaking, I should be able to just put common name and it'll grab all of the memory pools, but it didn't actually work out that way. So inverting them, as we see it falling in the hierarchy here, Java lang G1 eating space memory pool type was what was able to get it working for me there. And you see that when we do run it, that it tells you each of these sections if it was able to pull back any metrics and the number of metrics from there. But as you can see, the kind of common pattern is the M being attribute name here, and then the specific metrics. So I've gone through essentially all of these sections and chosen what I feel to be the relevant ones that we want to pull out about the, in the different sections, Jmx memory pool, memory status, garbage collector. I've tried to pull some things together so that we can have a look at and understand the generational memory usage and how the garbage collection processes are happening and what's going through the young what's it called, old gen, and the one in between. Can't remember what the middle one is called. Thread status is another interesting one that can just tell us, how many threads we have running as well as their thread states. So, this is a very high level figure, so it's not going to tell us specific threads and what their states are and how they're evolving, but, we can see things like active threads or block threads that potentially creep up over time, which can be an indicator for interesting things. At the very bottom, we've got our Influx Db configuration set up there. I'm running as much of this as I can kind of locally, and this is all in the same machine. We have Grafana, we have Influx DB, and we have the T-sample application all running on a very small, I believe it's 2-core, 4 GB virtual machine. So super small. It doesn't cost barely anything to run it on a monthly basis. You just need to create one of those sections for each of the environments that you want to monitor. You can obviously tweak the metrics and the settings that you want to pull from each. And then, you saw there was a deb package, so I'm using that to install this, and with that we can see here, I check the status of the service, and it's telling me that, here for example, this line here, mbeans query on the environment successfully got 1 Jmx mbeans from thread status metrics, and here it tells me which ones that it's gotten, and that's really how you can determine if you have any errors pulling them in if you get 0 metrics, for example. So that's running, and super, right? So that's bringing all those different things together, popping them into Influx, and now we want to look at them from Influx. And so looking at them from Influx looks like this. So across the top, we can see there's a number of configurations. There's a couple of different environments that were being pulled. This one is offline, but it's some data is still there. So this is the environment in question. Here I have the possibility to choose the persistence provider. I will note that this is used, what would be passed into those persistence provider related services. So this is only going to affect a very small portion of the panels and sections on the dashboard, but it will affect some of them. And then the subsection is kind of a weird one because it depends on the metrics area that we're talking about. Like here we can see there's this subsection about the memory pools type, right? Survivor space, that was what I was looking for before. This is around the memory pools. Here we have ones that are around HTTP NIO 8080, HTTP NIO 28080. These are all about the connectors for Tomcat, and so you can use these to be a little bit more specific for what you're looking for. If you're looking to represent a certain set or subset of information. We're just going to right now look at everything, but these have been designed so that you can kind of focus in a little bit. So, keeping in mind, I mentioned there's nothing else, there's nothing running specifically other than those two extensions. There's nothing specific that's running on ThingWorx here. And here we have the CPU utilization, and specifically I've called out free memory. You see here the total physical memory, total free physical memory. These ones are quite interesting because it's one thing to see what the heap size is, which we normally see down here, right? Coming from ThingWorx, is we see what the heap is set at. So we have the 5 gigabyte allocated in the heap, but here we actually see how much physical memory that the system has and the free physical memory as it evolves over time. And this is really interesting because I have sort of identified a problem remotely with, I think it was a virus scanning application that was essentially consuming all of the system resources at a particular time. And you kind of have to look beyond the curtain in your mind, but we saw clearly that ThingWorx was not doing anything differently, and was able to see these really massive free memory spikes where it just dropped down to nearly nothing for about 8 hours, which helped identify and triage that the problem was not at all related to ThingWorx, but something else running on the host. And same over here with the CPU utilization. The average is really weird. I really don't know how to interpret it, but it's related to the number of process cores you have. The more process cores you have, the higher the average is going to be. But in any case, for our purposes, this is showing us the system CPU utilization, and this one is the process CPU utilization. So here you can see this spike. I had restarted a stalled IoT Hub connector, so there was a lot of data that kind of came in, and ThingWorx was quite busy right here trying to process all this data. But what we see here is they're fully in line with one another, right? So the JVM is the busy process on the system. It's not always going to be, and once again here you can use this to sort of see, are you running something else on your environment that might be taking your resources without your knowledge. JVM, this is going to be long if I go through this at this particular pace. Classic ones, right? Heap, thread count, heap and non-heap. I wanted to bring the non-heap into this. We have the heap normally within ThingWorx, and here we kind of start to get a little bit more hardcore, I guess I could say. Here we have all of the different memory pools, but the usage compared to committed. This one, if you kind of just hit V over top of it, it can be kind of a nice single place for you to look at the varying memory pools, or you can come down to it's the next section, garbage collector section, where we're going to see the same type. This is a kind of all in one, and then this one is more of a view where we're going to break those out, and we're going to look at eat-in space, committed and used. And keep in mind, this is garbage collector section, so this is before and after essentially. One of these lines is before, one of them is after. And survivor space committed and used, meta space committed used, old gen committed and used. So here we see as we go from the garbage collection events, the things that are being busy, that are being used over here, are going to go into survivor space for one iteration. If they survive another garbage collection, they're going to go into old gen. So here we're going to see the stuff that's taking up memory over a longer period of time, and here are those kind of running tasks. And depending on how your application works, you'll see a mix of those, but just be cognizant that high eat-in space memory requirement means that you shouldn't also have high old gen requirement, right? Because we have to share the heap between the two. And these numbers don't really work, I would say, but the intention with these numbers is to essentially try and do a delta as well as a sum between the time spent doing garbage collection events. So here, for example, I can kind of promise you that it didn't spend 3.26 seconds doing garbage collection, but there were accumulation of multiple garbage collection events that totaled to a large number, and it shouldn't be 2 seconds, right? So this is effectively long garbage collection, and we can see a difference here where we had some form of event that happened here, where we had, a higher eat-in space, and then we actually go to a higher old gen, right? So we're transitioning this, and for whatever reason, it took a long time. Normally, you should have healthy means small and frequent, and not, not large. Like, what does it say here? 0 milliseconds, right? So Tomcat, the Tomcat, this is beautiful, frankly. I was able, depends on the JVM. It doesn't work on all JVM versions that I was seeing in this, but this is like magnificent, because here for Tomcat, we see the number of connections, how many clients you have coming in, whether they be WebSocket or whether be users. We see the number of HTTP requests as well as errors that are being processed. So if you just kind of want to have a quick look to see if there's any errors that are coming in, it's a great way to do it. The processing time, this is kind of one of those areas where it's a little bit fuzzy. We can say we do want to see average. On average, if we have a high volume, average is very important, but it can also really skew our numbers. If we have something that takes 5 seconds, it's going to throw your average off enormously. So, that's why I put the min, max, and average on here, and you can kind of see that they're following one another, right? So whatever is happening, this is quite stable, and this means the system was very busy right here because the min, max, and average follow one another, and we know that this is related to, that's why the lines kind of line up. We know that this was related to that event here, that the IoT Hub connector came back online. Network traffic, same. I mean, this is going to give us some indications. If we're just expecting to be executing a service, get a response, we shouldn't see a whole lot of network traffic. If we start to see huge amounts or spikes or kind of craziness in the network traffic, it's going to give us an indication of what's happening. Are people downloading huge files? Is caching not working? Whatever. Same with thread counts. If we have insufficiently provisioned or configured threads, then we're not going to be able to essentially put those threads in a Tomcat web application server in order to field and handle all the requests for clients. Conversely, if we have too many of them, we can also overwhelm ThingWorx. So it's somewhat of a balance to find. You know what? I'm not going to go to that. That's really a big part of the focus here, right? Because everything we just looked at here, none of this is available in ThingWorx natively. So now when we come down to the ThingWorx stuff, this is classic. We got the heap platform queue size. This is quite important. I pulled the uptime just so that we can see uptime and thing count. This isn't a detailed graph, but it does give you an idea over your period, your look back window, to see if people are provisioning things. If you start to see some change in behavior and you see that all of a sudden, like this, there was a large increase in number of provisioned things, then we can make some assumptions about maybe that was related. And it's the same with the WebSocket communications. I'm just basically stepping it up system by system, kind of moving up the solution stack. Active WebSocket connections, here you see the stable. This was the connector restart, as well as bound things and unbound things. This isn't going to work in all versions, but this can be quite handy also to see that, here we had 2 bound things, and once I restarted the connector, we picked up another 13 bound things. Bound things means more subscriptions that are going to execute, etc., etc. WebSocket execution processing. Here we start to get into some of the essential ones. Between the two of these, these are tasks that are coming in from WebSocket connections, and these are tasks that are going through the event router. Both of them, you can see I've tried to set things up in a standard fashion across the various systems where it's relevant, where we have the submitted and completed over here. to sort of ensure that there's no lag between the two, that we don't have submitted that are not getting completed. So we should have them tracking together. And then this is indicating the queue, if we do have queue buildup or not. This was that big spike that you can see was immediately addressed, so all good. Normal to have a built-up queue at a particular level, so it's fine if it's kind of floating around somewhere. What we certainly don't want to see is incremental buildup over a very long period of time, because that will get us to essentially a crash situation. Yeah, thread pool, same thing. This is really for, as we get into over to the right side here, is configuration support for tuning how the platform is. How many threads do you have provisioned? How often are they busy together, right? You don't want to have too many threads. You want to keep that small, but it needs to be right sized. If you have a small amount of threads, but they're constantly busy, then there's going to be waiting going on. So we need to find that good balance of across the various systems so that everything works nicely. And here I'm just calling out these values, and this is also why I'm pulling them in, is if you are going through a tuning process, they're being stored in Influx. So I can go back, a few weeks, a month, whatever, and I can kind of have a look at what the configurations were, like the core pool size. Okay, so here we start to get into some of the really important parts. Actually, this is, so this is C3PO. Helper threads, we saw those 16, right? But I mentioned earlier on that I'm summing them together. So this is why it says 20, because 16 plus 4, 20. So this is the combined pool size of all of your persistence providers. So if you don't want to see them all, you're going to have to go up to the top and select the specific one that you want, and we'll do that in a second. And then this is, once again, the combined number of tasks and cache statements across the multiple persistence providers. The reason I built it this way is if you're using the same database, but database server, what's it called, physical server versus logical server, and then you have a logical server on that physical server, you could have 5 logical servers that are sharing the same physical server, and yet the things like connections and resources are still all shared. And so that's why I'm summing them together here, is you'll want to ensure that you're looking at it not only from a specific persistence provider DB connection pool perspective, but also from the whole server perspective. And as we don't have any metrics from the DB server, this gives us a way of doing that and seeing, how many connections, for example, do I have to the database. Here you see 13 is not very shocking. I will show you something later that will start to become a little bit more shocking, but databases all have max connections, and the number of connections that you allow to the database are going to extremely impact the overall not only cost of your resources, but also how well the database is performing, as well as your ThingWorx application. So super important. This is probably the most important thing for tuning ThingWorx. Right, I said I was going to check one of those boxes, didn't I? So there is a kind of a hidden cool thing in the configuration I didn't mention, and this is this sub 16 sub 4 thing, where there's an option to essentially take that random token and replace it with a specified static lookup metric. So I mentioned having changed the number from 8, normally the default, to 16, and from 8 to 4, so that I can call out my 2 Azure SQL persistence providers here. So here I only want to look at the ThingWorx persistence provider, so I select sub 16, and sub 16 is then going to show me, has nothing to do with Tomcat, right? That's why nothing is showing up here, because I haven't selected those HTTP NIO2 8080. But for the C3PO section here, now I have the 16 pool size, and now I'm looking at specific statistics as well as errors and failures for the ThingWorx persistence provider. All right, I'm conscious that this is getting pretty long. There's a lot of stuff in here, so I hope it's not too much for everyone to digest. DBCP2 Pool 2, this is one, frankly, before putting this on here, I've never seen anyone capturing those metrics, but the purpose is sometimes people have an external database that they use for reporting, for MES Lite type functions, or these type of things where they're just using JDBC. This gives us a space to be able to monitor the number of connections to that, how those transactions are being executed, if there's errors, if there's disconnections over time. And then this is the persistence provider database. Yeah, this is the one that I was mentioning earlier that might not be so useful and doesn't have as many statistics. It's using the, you can probably delete this from the section here, but it's using that extension with the service that I showed earlier, as opposed to getting it from the Jmx. Jmx C3PO is far more accurate and detailed. Persistent property processing subsystem. This is what we're talking about with the persisted properties. As we have a property that changes, if we write it to property VTQ, there will be an enormous overhead for doing that update, and that multiplied out across hundreds or thousands of things, especially at high frequency, can essentially cripple the database. It's not really about ThingWorx issue, it's just about overwhelming the database. So that's very important. You can see the numbers were quite low there. So my system is not doing that presently, but I have set it up in the past to do so. And then value stream processing for most people is really a big area that they look at. In the Prometheus-based approach, I've really split this up as the metrics kind of present themselves from ThingWorx Persistence Provider and Influx Db. This is how they come in. Here we have the filtering capabilities, so we can go to the top and essentially choose the persistence provider that we want to see. Right now, as I mentioned, the goal has been to sum them all together, because it can be very difficult. If you imagine your ThingWorx environment, you want to know how many writes per second that you have. If you have 50 different persistence providers, I don't want to say it's impossible, but very difficult to understand where those writes are coming in and when, and how they kind of accumulate together, especially when each of the persistence providers have their own DB connections as well as own queues. So this is where I've spent a fair amount of time around here to try and give the tools to be able to dissect and analyze those metrics across different persistence providers. So just to make that really clear, provider up here, Azure SQL data persistence provider, and now I'm only going to see Azure SQL data persistence provider. So absolutely nothing happening on here, right? Scan rate, I can look at the configurations, and I have 5 processing threads here configured. Okay, all. And so going back to finish up, stream is the same. I will say these 3 boxes at the bottom depend on your ThingWorx version. They're not in all things. The other nice thing about this is, as establishing a baseline before you're upgrading from something like, if you have an 8.3 or 8.4 or 8.5, setting this up before you do a move can give you an idea of how healthy and performant your application is running, so that you can potentially identify and address some of the issues during the migration process, as opposed to migrating it and then kind of falsely believing that maybe some of the issues that you're seeing are related to the upgrade that you've done. If you have the metrics that you're collecting in this fashion, which is compatible with pre-9 as well as post-9, you can do the upgrade, and then you can really compare the numbers, like numbers of value streams writes, for example, before the upgrade and after, and use that to ensure that everything is running smoothly. So same for stream processing here. We've got that kind of common pattern, right? Submitted, executed, and queue status, maximum queue size per thread. This is not selected, so it doesn't screw up the table here, but this just gives you an idea to sort of remind you that depending on the number of threads that you have, you're going to have a number of events that are spread across each of those threads because the queue is divided across the number of processing threads. Yeah, so here max queue size, right? 500,000, 5, meaning each thread is going to have a max queue size of 100,000. And same for data table processing. Depending on what and how much you're doing with data table processing, this can be a big source of performance challenges. And so surfacing this in conjunction with those other ones will give you an idea on the frequency as well as status of any data table calls that you're doing. So that was quite long. Sorry for the length, but as I say, it's a deep topic. There's no alerting that I've done in here, notifications, but and this has really been designed with the intention that people will take it and kind of cut it up, delete stuff that you don't want, as well if you want to make panels or move it around. By all means, go for it. But the core goal has been to bring this type of monitoring to the people that need it, and that is everyone that is using ThingWorx on a daily basis, whether you're a developer, an architect, or what have you. There's just so many questions you'll never be able to answer unless these types of metrics are being captured and stored over time. And you can really use this as a beneficial tool. I guess there is one final thing I wanted to show you was that's just a test system. This is a production system, and I mentioned that the database connection pools or the C3PO metrics here is going to be the most important area for you to be monitoring, because this can lead to, especially if you have a lot of persistence providers, this can lead to crashing. This can lead to DB overwhelming because just configuration in ThingWorx. So here we have there's more than 100 persistence providers that are being summed together to provide us this kind of view here. But you can see 300 odd connections to the DB. And at some point in time, this is going up by 130. So one does wonder what's going on here, especially because only 53 of them are busy. But this is a normal operation for persistence providers. As busyness happens, we reallocate more threads if we haven't reached our max thread size. But this type of spike can also overwhelm the DB and put the system down. So here we see no errors. Frankly, everything is fine here because this is a really big database. But if we go back a little bit further, let's go for 3 months. Maybe that was a bad idea. Because of how the summing is going on here, these queries right now that are happening this is what I was referring to, not very optimal, because it's not doing the time windowing in the same fashion that you would normally do time windowing to make such a query effective, because I can't, because I need to sum them together appropriately to get the cumulative value. Okay. And that's also why it looks so fuzzy, because we're not, we do have a lot of data points in here. But you can see here, and this was exactly the point that I was kind of going for, is you've got this standard normal operation baseline here, but you do see these spikes that pop up every once in a while that are quite high. This one goes up to 920 connections to the database, and you can see down here there's failed tests to the database as well. So we do know that there's some issues here. This is probably not lasting very long. If we kind of just come and zoom in over here, it's probably just something that happens and then is resolved, without anyone really noticing, but um, these are potential issues. There was a database check that was attempted and it failed. If it gets resolved right away, that's fine, no harm. But if the connections are all monopolized, then that means other services that you're going to be running are not going to be able to have access to them. I'm not going to go and pick the other ones out of here, but basically you can go and choose those values from the top and compare as we dare. These are connections to the database. Do the same thing with value stream processing, right? So I've zoomed in on that particular area. Now we're thinking about, I want to know where those database connections are coming from. You're wondering if they're coming from value streams, are they coming from stream processing? So here I've opened up the value stream processing, and we can see that there are some value stream processing spikes that are coming up there. I will actually use the opportunity to point out that it's possible that this is an error. There is a known issue that I've seen in the T-sample tool where it's on a 30-second pull rate, and instead of going like 0, 30, 0, 30, 0, 30, within a 30-second time window, it can get two values when it restarts. So instead of being like 0, 30, 0, it might be 0, 29, 59, 2. So they're not 30 seconds spaced apart. So if we were to take one of those 30-second intervals, we'd actually be summing two polling results. And that's just a bug in how the T-sample tool works, but can make some very short spikes like this that look very high that are nothing to worry about, as long as they are only for like one interval. That should fix after the next interval. And so, stream processing. I should have zoomed in a little bit further to make this faster. With the panels collapsed, Grafana isn't going to load the data, so to keep this running smoothly as you're navigating around through time, it's best to kind of collapse them. In any case, this kind of gives us an idea specifically of how the queue is behaving, and you can see here that the queue is never getting over 1500 for all of the combined persistence providers, so it's quite healthy. At the same time, how far back did I go? Cancel. It's not always healthy, and there are some things, if we just kind of look back quickly over time here, if 6 months. Okay, and have a look at this. Okay, in any case, we've done a very good, this was something that we did see. You can see here the thread count kind of crazy going through the roof, obviously not good. not being terminated, platform subsystem. Here you can see, I'm just showing you some of the observations that you can quickly see here. Heap size change, application is kind of changed over here based on the number of devices that were provisioned. Processing subsystem, pretty good coming from Kepware, right? This is a pretty basic system. This is a good, good level of busyness based on the threads that are provisioned. And event processing, we're probably going to see something quite different here. So for the event processing, this level of busyness here on the event thread pool could potentially have some issues where Composer starts to become a little bit slow in responding if they last for too long. I don't know how much we've zoomed in here. 525, 30. So this is week. This is the week. So, like right around here, if we have a look in here, this particular period of time depends on how. Yeah, so this was only a short spike, but you can see that number of threads provisioned are active, fully active, and this is for a very short period of time. So something has happened here that has essentially made ThingWorx to be so busy that it's spreading out and parallelizing as much as possible to do the work that has been requested of it, to which point other things like Composer are going to have a hard time responding to users at the same time. So this is fine if it's short, but this is the type of thing you want to watch out for, this type of peakiness, because we've multiplied by more than 10 the number of threads that are being used here in the span of a second. Hope you found this interesting. I understand that it's quite long. I'm closing this book for the time being. There's a lot of other exciting things for me to take from here and move on with. And this video is meant to be kind of a purpose to pass it out to the community, as well as remember for the next time I have to pick this up. Have a great day.